Okay, welcome back to grade 9 Applied Mathematics. We're continuing our work in Unit 5. So far we've looked at rates of change with positive correlation, rates of change with negative correlation, and in the last lesson, which was lesson 3, we were looking at determining whether or not a relationship is linear by looking at its table of values, its graph, or rate triangles. And what we're going to do for the balance of this unit now is focus specifically on lines or linear relationships. So the first thing we're going to think about is play a little game. It's called What's My Line? So I would start class now by telling you I'm thinking of one of the cables on this bridge. This is the Brooklyn Bridge across the top. Which cable am I thinking of? And my description of this particular cable is it's steep. And so you're going to pick one of the cables based on my description. And what we're going to do now is we're going to do a time to ponder pause so that you can give some thought to which cable you would like to pick. All right, so taking this up, did you pick one of the cables? So I said the cable is steep. Let's see if I can find which cable I had selected here. There it is right there. So there's the cable I had selected. Did you pick that cable? And let's imagine that this was a math assessment. And if the goal was for you to pick the cable that I had selected, was the description I gave you fulsome enough for you to pick the correct cable? And I think we could successfully argue here, no, not fulsome enough. Now, if I had said steep with positive correlation, at least we could be eliminating the ones on the right-hand side because they all seem to be pitched with negative correlation. There's a whole bunch from this side over that are fairly steep that have positive correlation. And again, on this side, we could eliminate those ones because they don't look as steep. So the purpose of this lesson, now, if we were meeting as a group, you would be working with a partner. And the objective for you would be to figure out, well, then what would make a better description? How could we have narrowed this down to just this specific cable given all the choices we have there? So the first thing we would do, now if we were meeting face to face, there would be one of your partners would get a circle with a line on it and the other one would get a blank one, and then you would describe the line to your partner. Now clearly we can't do that here because we're not meeting face to face. So what I'm going to get you to do is look at the description I've given. I said it has negative correlation. It's not very steep. Which one of these could be the line I am talking about? And once again, it's a time to ponder pause. Okay, so resuming, we'll move forward. And descriptors, it could have applied to either of these two lines. This line has positive correlation. It would be out. This one has positive correlation, so it wouldn't satisfy the descriptor. This one has negative correlation, but I would argue that that's fairly steep. So there were two lines here that had negative correlation, not very steep. So that description was not powerful enough to help us determine which of these would have been the correct line. Again, we've got a circle here, so there really is no clue as to how we could orient it, right? I could pick this one up and I could start rotating it. And eventually I could make a line with negative correlation. There we are, negative correlation. And there's a whole range of spots where it could be where we would say not too steep. So what we're going to do is we're going to move to a different grid. And again, if we were meeting face to face, you would have one grid, could have the line, or maybe it doesn't have the line, and you or your partner would take turns describing the line and you would attempt to draw them. So I would ask you to be thinking about, here's where we started, and then I just showed you how I could take that and I could just spin it. Infinite number of orientations I could put that in, and there would be a lot of them that would have correlations that were negative. What does this grid add to? Does it add information that would allow us to eliminate some of the options? I'm going to get you to think about that. The descriptor for this line now is positive correlation and it's steep. And once again, a time to ponder pause. Okay, resuming and having a bit of a one-sided discussion here. So positive correlation. This has negative correlation, it would be out. This one has negative correlation, it would have been out. This one has positive correlation, but we could argue that's not very steep. And of course, these are the two possible orientations that would give us positive correlation and steep. And now I also asked you to think about, we started with a circular grid, if you would like. or just a circular shape. Now I've moved to a square, and would that help eliminate some choices? I would argue yes, because when I hand these out in class, I only see 4 orientations. It could go this way, this way, this way, or this way. So I see it oriented one of 4 ways. And of course, you know, we could flip this as well. Let's flip it left, right now. And then again, 4 possible orientations if I give you a clear or a transparent acetate for doing this. So what's happening over here is we still are not able to eliminate all of the possible choices because we're no longer the circle. There's 2 possible ways we could have oriented this so that it has positive correlation. All right, let's move on to the next one, next example. So here's the next example. Now, how does this grid look different from this grid? Sometimes in class, what students will say when they're attempting to have someone draw this is they'll tell them to start here, and then they'll kind of direct them where to move on the other side of this particular grid. So this one kind of introduced a way to measure. There's no way to measure on this particular one because it is a circle. Even though when I'm spinning it, it appears like a square. When I give this to you, it would definitely be a circle. There'd be no way to measure here. This one gives us the potential of measuring. And this would be the 3rd grid I would hand out. Again, I can't describe this to you, so I'm just going to keep it simple in my sort of description. My description now is saying what I would like you to do is find a line that is moving so that it has a slope that would be right 1 and then up 2, right 1 and up 2. And again, a time to ponder pause. Okay, resuming, just taking you forward and showing the 2 possibilities that it could be. So this is going right 1 and then up 2, right 1 and then up 2, and then in this particular case, maybe we're just going right 1/2 and then up 1, which would be similar. I'm going to give you a definition. Lattice points are where the curve meets grid marking. So that's happening here, it's happening here, and it's also happening there. So if I'm going to try and decide what the slope is, I don't want to guess at this particular point here. So I'm going to go for a known lattice point. This is going right 1 and up 2, right 1 and up 2. Finding lattice points over here, 1 there, there's another one here, and of course there was 1 in the corner. This is going right 2 and down 1, right 2 and down 1. So that's not correct. I'll mark the lattice points on this one. And again, a lattice point is where the curve crosses where 2 grid lines meet. And this one is going left 2 and up 1, left 2 and up 1. And then marking the grid marking, or not the grid markings, the lattice points on this one. There they all are. We're going right 1, down 2, right 1, down 2. So when I encounter a line that has a much better way to measure, this one has a better way to measure than this one did, because this one was just one great big huge square, no smaller grid square markings in there. I made it more challenging to measure. This one has a lot more smaller grids in it, which allows me to find what I'm going to call lattice points. So I could find several lattice points. There are no lattice points in this one. That's not meeting at a marking. In fact, we only have lattice points. There are 4 of them, 1 on each corner. So this grid makes it easier because it has more lattice markings. So we were able to find 2, though, that had the correct slope. That was right 1 and up 2. So in math, we don't want there to be multiple lines that we could draw from one description. So the next piece would be, well, what could we do next to narrow this down so that we get absolutely 1 line? So let's take a look and see now, what do these grids offer that the previous one couldn't, that might now be able to limit our choice to absolutely just 1 single line. So the description here now is that you should start at 0, 1. You should move 2 right and 3 up, or you could move 2 to the left and 3 down. And once again, it's a time to ponder pause and see if you can figure out which line or lines would meet that description. All right, resuming and discussing this. So let's take this one up. So we're looking for starting at 0, 1. That would be the y or the vertical intercept. So let's see how many graphs satisfy that. This one does. This one does not. This one starts at 0, 2. 0, negative 2. This one starts at 0, negative 2. This one starts at 0, 1. And this one also starts or passes through the point 0, 1. And then we were asked to move 2 to the right and 3 up. So let's check that. We are going 2 to the right and 3 up to that next lattice point. And then it also says that we could describe the lattice points, instead of moving right and up, we could describe it as moving left and down. So we can move 2 to the left and 3 down. 2 to the left and 3 down. And notice now we've traced out every single lattice point in this particular line. If we were going to describe the movements on this particular one, so if we were to start at the y-intercept and take a look at what's happening, we're going 2 right and 3 up to get to the next lattice point. 2 right and 3 up to get to the next lattice point. And this would be 2 to the left and 3 down. So at least this is describing the correct slope. We have the correct slope on this one, but we are not starting in the correct point. Now let's take a look at this one. Here is our start point at 0, negative 2. We are going 2 to the right and 3 down, but we were supposed to go 2 to the right and 3 up. Or alternately, we are going 2 to the left and 3 up, 2 to the left and 3 up. And of course, our descriptor was 2 left and 3 down. So this one doesn't have the correct slope, nor does it have the correct start point. This one has the correct start point. We are starting at 0, 1, but now we are moving 3 to the right and 2 up. We were asked to do 2 to the right and 3 up. We are going 3 to the left and down 2. We were asked to go 2 to the left and down 3. So this particular graph starts in the correct place, but it doesn't have the correct slope. And we did note, we indicated where every single lattice point was. Now let's take a look at the last one. Again, this is starting at the correct start point. We are starting at 0, 1, but now we are going 2 to the right and 3 down. 2 to the right and 3 down. So it's the correct move to the right, but we're going in the wrong direction. Instead of up, we're going down. And in this direction, that's 2 to the left and 3 up, but we should be going 2 to the left and 3 down. So now we've seen that there's absolutely only one way, to draw this. If we indicate a starting point being your y-intercept, and then we describe a slope, there'll only be one line. So we saw there were several lines that could have the same y-intercept. There was another line that could have the same slope, but putting the two together, we've got a unique line. So that's going to take me to the next slide, something for you to think about. So if you want someone to draw an accurate line, what are the most important characteristics for you to include in your description if you want your partner to either draw, as you would have done in class, or here I just had you pick out the correct line. What is it you feel you need to include? And again, it's a time to ponder pause. All right, resuming. You want to get them to move to the correct start point, and of course the correct start point is going to be a y-intercept. So we got you to this point right here, which was the y-intercept. And then to get the correct steepness, we described a slope in terms of left-right moves and up-down moves to travel from one lattice point to the next. So you should indicate, mark on all the lattice points, and again, that's where your line or your curve intersects two grid lines. And so our slope in this case would be 2 right and 3 up. All right, so let's come back to where we started. What's my line? So I'm focusing on, this is a different, I guess, cable. So what cable am I thinking about in here? So to help you get to the correct cable, I've told you where to start. And then I suggested you go down 3 and left 2, down 3, left 2, down 3, left 2. This is where we started out with. There was absolutely no grid. If I wanted you to pick this cable or this cable, not easy to give a fulsome descriptor that would lead you to that particular line. But now when I overlay a grid on it, and then I say I want you to start from here, and then go down 3, left 2, you can see there's only absolutely one cable we would pick. I have marked on other cables, and if you want, you can try and give descriptors of some of these other cables. The question I'm going to get you to think about right now is, why didn't I come back to my original line, which was this one here? Why didn't I try to create a descriptor for this one? Again, time to ponder pause. Okay, resuming. The reason I did not pick this particular one is if we take a look, there's absolutely no lattice points. This line is running in between these two x values or horizontal values, and we don't hit a single lattice point all the way along. So I was not going to be able to write a good description of that one simply because that curve doesn't touch any lattice points. All right, so let's move to this one here. What I'm going to get you to do is write a description. We'll do both at the same time. Write a description for this line, and the descriptor I'm after is really a slope descriptor. And write a description for this line to the right. So once again, a time to ponder pause, and I'm going to suggest that what you should do is mark every single lattice point. That would be your starting point. Once every lattice point is marked, then think of how to describe that in terms of left, right, and up, down moves. Again, a time to ponder pause. All right, so taking this one up, marking all the lattice points. There's one there, there was one here, there's a lattice point here, there's a lattice point right there. I'll make those a little bigger now. So those were all the lattice points. So I had marked a start point for you, so I would just say from the start point, what we should do to get to the next lattice point is move 2 units right, 1 unit up. 2 units right, 1 unit up, 2 units right, 1 unit up, 2 units right, 1 unit up. So that would be a good descriptor of this particular line. If I were to start here and say, there was my start point, go 2 units right and 1 unit up, 2 units right and 1 unit up, I would get a line that has the exact same slope or steepness as this one, but it's not the exact same line because I chose to start in a different place. So in order to get this line, we're going to have to get everyone starting right here. And for this next particular line, sliding across, looking for lattice points, there was a lattice point right there. Sliding across, there's another lattice point right there. And then I'm simply going to describe. Slope is really a description on how to move from one lattice point to another. The moves are always made heading to the right for the independent variable. So now we're going 3 units to the right and 2 units down. 3 units to the right and 2 units down. And we couldn't continue this because we only had room to go 2 units to the right. We would need to go 3 units to the right before we could then go 2 units down. So those are good descriptors. Where is the start point? It had been already marked for us. And then we have a descriptor of the slope in terms of left, right, and up, down moves. All right, what are we going to try next? All right, so now I am giving you the following description, and then you're going to try to draw the line. So plot any starting point you want, and to get the correct steepness, I would like you to move 2 squares to the right and 3 squares down. Continue that pattern until you can no longer plot any more lattice points, and then draw your line. On this particular one down here, I'd like you to pick any starting point you want. To get the correct steepness, move 1 square to the left and then 4 up, and continue that pattern and extend your line fully across the grid. And once again, it's a time to ponder pause. All right, so taking it up, I chose to start here, and then I just want you to notice I do have the correct steepness. I'm moving 2 to the right and 3 down, 2 to the right and 3 down. But you could have picked this up, and this could be positioned anywhere, but we do need to position it at a lattice point. So it could have been here, it could be here, it could be there. I mean, I'm not going to count all of the lattice points on here, but you could count all the lattice points. We obviously wouldn't want to start there, because if we started there, we would not be able to get another lattice point in on the grid. So we'd have to pick a spot so that we could get at least a second point in. So we could start there. And we can't move any further to the right or any further down from here if we want to get a second lattice point in. Again, I'm going to put that back where I started, which was right about there. All right, looking at the next line, start anywhere I want. I chose to start here. I extended this line completely across the whole grid. I didn't on this side, so I suppose I could have drawn, just trying to continue that, trying to continue it off that way, but we should really use a ruler to do that. So in this particular case, this was my start point, and I'm moving 1 to the left and then 1, 2, 3, 4 up. Again, do not count this as 1. We are counting the number of full squares. We're not counting the number of lines as we move up. We're counting the number of blocks. So when I get here, I've moved 1 unit up, 2 units up, 3 units up. There's the 4th unit up as a move. That's 1 unit to the right. Now this is 1 unit up, 2 units up, 3 units up, and that one is 4 units up. Students mistakenly try to count the lines. If you're going to count the lines, then the first line has to be 0, because by the time I get to here, I have not moved up at all. So 0 units up, 1 unit up, 2 units up, 3 units up, and 4 units up. And again, then I can take this and I can position, let me just grab this bit, I can position this somewhere else on the grid, because I did say you were free to choose a starting point. So there's lots of places we could put this. We do want to be starting at a lattice point though. All right, so hopefully we're getting the idea. You need a start point and then you need a descriptor of the slope. All right, what are we going to try here? I would like you to write a description of each of these lines. And remember, I tried to give you a little hint here that in math, the start point would be given by the y-intercept. I've indicated that for you in these red points here. And so you're going to tell someone where to start, and then you're going to give a good description of each line, trying to describe the slope. And remember, what you really need to do is find all of the lattice points. That will help you come up with good slope descriptors. Once again, another time to ponder pause. All right, resuming. So the first thing I did was, on this particular line, is I located all of the lattice points. There they all are. And then I looked at that. That has gone 1 full unit to the right. There's 1 unit, 1 full unit to the left, I should say. That's 1 full unit up, 2 full units up, and 3 full units up. So I'm going to start right here. That's the point 0, -4. So I'm going to tell someone start at the point 0, -4. Move 1 unit left, and then 3 units up to get to the next lattice point. Repeat that. 1 unit left, 1, 2, 3 units up. I'm at the next lattice point. 1 unit left, 1, 2, 3 units up, and I'm at the next lattice point. And then we repeat that until we go off the grid. So on this next particular point here, I'm going to start right here. There is the start point. The start point is the y-intercept. There were 2 other lattice points on the line, one occurring right here and one occurring in that corner. And to get from this lattice point to this one, I'm counting my moves. That's 1 full unit, 2, 3 full units, 4, 5. 5 full units to the right, followed by 1 unit up now, 2 units up, and 3 units up. So we could move 5 to the right and 3 units up to get to that lattice point. Now, to get to the lattice point down here, I'd have to describe it differently if I want to come from this start. That would be going 1 unit left, 2 units left, 3 units left, 4 units left, 5 units left, and 1, 2, 3 units down. I would still have the same descriptor, though. If I started here and I wanted to go to there, I would use the same descriptor as from here to there. That could be also viewed as heading in this direction. That's 5 units to the right, 3 units up. Or we could view that as 3 units left, or 5 units left, and 3 units down. So there's 2 ways you could describe these slopes, depending upon whether you're heading in a left direction or you're heading in a right direction. In this particular case, if I wanted to describe coming to the right, that would be 1 unit to the right and followed by 3 units down, whereas I had suggested 1 unit to the left and 3 units up. All right, one more set of examples to look at. You're going to try and draw these lines accurately. The y-intercept is -1, and your slope is -2/3. And sort of to help you out here, you could view that as -2/3. So this would be your up-down move. Or you could view this as 2/-3. So we could have a -2 up-down move and a +3 left-right. Or you could have a +2 up-down and a -3 left-right. And in this particular case, we can view this as 4/1, because right now I can see that's an up-down move. What is my left-right move? I'm going to see that as 4/1. You could also view this as -4/-1. All right, so what I want you to do is start with the y-intercept, and then I want absolutely every lattice point to be plotted, and then you draw a line through it. And it's our final time to ponder pause. All right, so taking up our last question of the day. So I started at my y-intercept of -1, and I did say we could view this as -2/3, or it was also possible to view it as 2/3. In this particular case, this would be going to the right 3 and down 2. So there's my move of 1, 2, 3 right, followed by 2 down. That's how I got that next lattice point. And then starting from here, we could be going, this is my up-down move. This is 3 to the left now. So 3 to the left and then 2 up. And what I haven't done here is, I should really be drawing a line through this. So I'm just going to draw a shorter line for now, and then I will extend it on the other end once I'm happy with that. That doesn't look too bad. And now, click. And then I'm still trying to make sure that that's passing through. So extending it all the way across the grid, there would be my line. So notice I started by plotting the lattice points, and once I had every single possible lattice point on, I can't get any other lattice points on because I only have 2 moves left in the left-right direction. Not enough room to move 3, so there was only 2 additional lattice points I could plot. Moving on to this particular case, I started with the lattice point of 0, 4, and taking a look at that slope, right 1 and up 4, there was no room to go right 1 and up 4, so I was going to have to view it the other way. I did say we could view this as -4/-1, because a negative divided by a negative is still a positive, so then there is the 1 to the left, followed by 1, 2, 3, 4 down, 1 to the left, followed by 1, 2, 3, 4 down, and then to finish off I need my line, so let me go grab the line tool here, start here, make sure I pass through that lattice point. That doesn't look too bad. Then go grab the other end and drop it like this. This would be easier, should be easier for you. Use a clear ruler when you do this. And there we go. So hopefully, what should we have gotten out of this lesson? In order to draw an accurate line, we now feel we need the y-intercept because that's going to be our starting point, and we need a way to describe slope. So if you feel you've mastered that concept, you've understood fully everything I would like you to get out of this first lesson. If you made it to the end, once again, thank you for watching. Don't forget to like and subscribe. And as always, take care and stay safe.